You guys can see the slide?
Yes.
Okay, good. Okay, so this is the last part of telecommunication. Today we're going to, our focus is about attenuation today. Attenuation today. I think I already told you that we're going to, what is the purpose of today's lesson is to help the telecommunication companies to find the maximum distance you can put the amplifier, because it's very important for the companies. Why? To save costs. Okay, to save costs, we need to put the amplifier as further distance as possible, but at the same time, never lose the signal. Okay, yeah. So that's what we are trying to do. Where's the furthest distance you can put the amplifier? Okay, so let's understand about attenuation. Okay, so attenuation means, as I said, reduction of energy, reduction of energy in transmission, or can say reduction of signal power when it transmitted. It's exactly analog to damping. Damping also is a phenomenon where oscillation loses energy. Here, the signal loses energy. Signal. It's also some sort of oscillation, but the term is attenuation. Like for example, sound. They said sound. When someone talk, they said, oh, very difficult to hear him because the sound has been attenuated. They won't say damping. Okay, sound attenuated. Oscillation is damping. Okay, what causes attenuation? In the metal wire, when electrical signal transmitted along a metal wire, it gradually loses power due to thermal vibration, thermal energy overcoming resistance of the wire. Okay, some energy loss as heat energy through the wire, so energy lost. So attenuation happens. Wire pair, the attenuation is very high because the resistance is high. Coaxial cable reasonably okay, but optic fiber attenuation is very, very low. Very low. Yeah. The small amount of electromagnetic radiation emitted by the current. Yeah. In optic fibers also attenuation happens, but optic fibers energy has been absorbed by impurities inside the optic fiber. Okay. The glass and by scattering due to imperfections. Yeah. Due to impurities. There is some impurities in optic fiber which absorbs some power, but very little. Optic fiber loses energy very little compared to metal wire. Metal wire energy loss due to heat is very significant compared to energy loss by optic fiber due to absorptions, very little. Okay. So electromagnetic wave lost power through absorption and dispersion through the medium. Like you send to the microwave to the air, the atmosphere going to absorb some electromagnetic wave, and the electromagnetic wave also sometimes disperse. When dispersed, the energy is not focused, then loses a signal. So the reduction in the signal power is referred to as attenuation. Okay. Okay, that's attenuation, reduction in signal power. To overcome attenuation, we have to do amplification. Okay, we have to do amplification. The signal need to be amplified consistently so that the signal strength is always at a certain minimum value at least. If the signal strength drop further down, then you can't get the signal. Okay, so first point. In order that the signal may be detected adequately, its power must be minimum number of times greater than the power associated with the noise. Yes, correct. Okay. The signal is stronger. Okay. What their first point is trying to say. Of course, the signal is like this big, but when get further distance, it get weaker. But at the same time, noise is picked up. Noise is picked up. Okay, getting even smaller noise is picked up. But when you do amplification back, okay, the noise is like the cancer cell. The original signal power, the signal power over the noise power must have a certain ratio, maybe more than 100 most of the time. The signal power must be 100 times much more stronger than the noise power Then when you do amplification, the signal power trend still reasonably reasonably kept in stock. The pattern won't be altered. But if it become less than 100, you do amplification also, the signal has been loses its pattern slightly, and the production going to be very bad. Okay, so before when the wave travel, what happened? The signal power is reducing, at the same time noise power is rising. So the ratio of signal to noise will drop. So when you go further distance, the ratio of signal to power will drop. Okay, so they have to do amplification before. So at the beginning, maybe if you signal to noise ratio may be 2000. So when allowed to transmit, okay, by the time reach about 100, the company must do what? Must build a tower, must do amplification. Amplification is critical to be done. If they put the tower mistakenly a little further away, pointless. They lose the signal. Okay, so we're going to find this distance. That's our ultimate today. Any questions? No questions. Hope you understand. So the signal power must be at least 100 times greater than the noise power. To when do amplification, we can recover the signals pattern. Okay, that's the thing. The typical signal to noise ratio could be 100. Okay. Okay, the repeater amplifier may be required to increase the power of a signal that is being passed along a transmission line. Of course, amplifier uses what? Op-amp. Op-amp is used. The gain of op-amp is 10 to the power of 5. The ratio of the output power and the input could be 10 to the power of 5, but normally we use a non-inverting inverting amplifier, which has a feedback. So the gain will be smaller, depend what gain you want. Okay. Okay. The radio link between the Earth and the geostationary satellite. Okay. The amplification is very critical for satellite signals. Why? Because the only place you can amplify the signal is at the satellite. You can't do amplification in between. So it's very highly attenuated signal will reach the satellite. So satellite does two jobs. What is the job of satellite? To reflect the signal to the Earth. Another one function is amplification is done at the satellite. Satellite got two jobs. To reflect the signal at the same time to amplify the incoming signal. Sent back to the Earth. That's the function of satellite. Okay. So the power received by the satellite may be 10 to the power of 19 times smaller than that transmitted from the Earth. Yeah, so highly attenuated. Okay. So whenever, because of attenuation, there is a need for amplification. Okay, you need to amplify the signal. Now we are slowly getting into the formula. Okay, the attenuation, the comparing power level to number of involved, the ratio of very large and very small. Okay, attenuation is calculated in terms of bells. Bell is the unit for attenuation and also amplification. Both are bells. Okay, okay, but more famous is decibels. Deci. Bell is actually, what is bell? Bell is log P1 over P2. The ratio of the power, the output power over the input power. So output power over input power. But I'm going to teach you like this. The power on top is the big power. The power at the bottom is the small power. Okay, for example is what? If you have a cable, this is your input power. And after the signal travel maybe a few distance, at the edge is the output power. Okay. So let's say attenuation happened. For the case of attenuation, input greater, output greater. Attenuation. Attenuation, input greater, right? Okay. So input greater than output for attenuation. So what do? When you calculate the bells, the top power, you put the big power. Which is the big power here? Input. So you put on top, input, down is output. For the case of what? For attenuation. Okay. Remember, the top power, the big power we're going to place. The bottom power, we go for the smaller power. For case of attenuation, input greater than output. So on top is input, down is output. Okay, one way of doing it. Okay, let's say the signal passes an amplifier. Input, amplifier input, and output. The amplification also calculated in terms of bells. How many bells is the amplification? So log, you put big power on top. So in this case, which power you will put on top? Input bigger or output bigger when we do amplification? Output bigger, right? For amplification. For case of amplification, on top you put output over input. Okay, understand? So always put the big power on top. Okay, so I think we don't follow this. We don't follow this. Okay, we don't follow this. Okay, so now the bell is log P1 over P2, and this the bell value. Okay. First of all, why they use log value is because the power going to be two different power divide, you get a number like 10 to the power of 6, 10 to the power of 7, very large number. So they say better use bells. When you log a number, the number going to be very small. Okay, log 10,000. How much you got? Log 10,000. You got 3, right? Log 10,000. Right? 10,000. Sorry, it's equals to 4, right? 4. So the number getting smaller and nice rounded. Okay. So that's why log values is used. Bell is used. Another one reason is later when I do questions, I tell you why you need bells. Okay, that is one advantage, but I can't show you here now. Okay, okay, I can put it in a simple way. When you have two tower, okay, let me clear this. Okay, let's say you have attenuation. You have attenuation of 20 decibel. Okay, and then this is your amplification. You got amplification of let's say 10 decibel. Then later you got attenuation again. Let's say amplification. Let's say 40 decibel. 40 decibel. Then you got attenuation again 20 decibel. Then you put another amplifier. Amplification is 80 decibel. What is the total amplification? Total amplification in this entire process. So what do you do? The attenuation we take negative 20. The amplification is negative 20 decibel. Amplification is positive 40. Attenuation again negative 20. Attenuation means negative, negative 20. And here amplification is plus 80. You get the total amplification. So in this case is how much? 80 decibel positive. So what is the another plus of using decibel is you can simply add them. You can simply add all the amplification to find the total amplification instead of multiplying or division. Just easily can be added. Okay, because you see, you have first amplification. Okay, let me clear this. You have one amplification, you have another amplification. This is power 1, amplified become power 2, amplified again become power 3. Correct? What is the first amplification value? The amplification of the first one. First amplification is what? The first one? 10 log. Which power over which power? The big over small. Big or small is what? Which is big? P1 big or P2 big? It's all amplification. Amplification. P1 big or P2 big? P2 big, right? Because amplification. Right? So we put which power on top? P2 over P1. This is the amplification for the first one. Okay. Now you do amplification for the second one. How do you put the power for the second one? For the second one, 10 log, what is that? P3 over P2, correct? P3 greater than P2, right? For the second amplification. Okay. Okay, now let's say the question asks, what is the total amplification? Total amplification. Total amplification, if this given P1, P2, P3, total amplification is the input is 1. Okay, the input is what? The input is 1. The output is P3 total to get the total. So total amplification should be what? 10 log P3 over P1. That is the total amplification.
Sir, is input or output actually?
Yeah.
It's top
Oh,
one input or output.
yeah. The signal is going from the left to right. So the one is the input.
So input should be top, right? Mm.
Okay, okay. What the way I'm teaching you? The power on top must be the big one. The big power you put it on top.
Okay.
Many ways to do. I'm following this way. I put the big power on top. So you decide which one is big. If amplification, output will be big. That's input. Okay.
Okay.
Okay. Now, so total amplification 10 log P3 or P1, right? But we see, you see, what is it? Why decibel is quite good? Why we use decibel? Is you see the 10 log P3 over P1. P3 over P1 we can write like this: P3 over P1 times P1 P3 over P2 times P2 over P1. Can we write like this? P3 over P2 times P2 over P1. It's the same as P3 over P1, right?
Plus.
So can you see the reason why we use decibel? You see 10 log, this is what mathematically P3 over P2. Then what happened? P3 over P2 plus with 10 log. Yeah, 10 log, this is plus, right? So you get 10 log P2 over P1, correct? P2 over P1. So this is what? This is the amplification of the P3, P2 amplification of the second one. This is the amplification of the second one plus, sorry, second amplification. And this is the amplification of the first one. So all just decibel. So what happened to finally decibel? Do you divide times? You just add it. You add it to find the total amplification. So what is the benefit of using decibel? We use decibel because the total amplification and attenuation can be found by adding their at decibel values instead of multiplying or dividing. That's the reason they use decibel. Good idea? Any questions? Understand why we use decibel? Because one past year they asked, why do you use decibel? So you have to say, instead of multiplying and division to get a total amplification or attenuation, the total value can be found by adding all the attenuation values. Okay, good. So as I said, please cut the last few points. Put in your mind, the top power is always greater than the bottom power. Okay, one example. The gain of amplifier is 45 decibel. Okay, 45 decibel. Okay, the output power. The input power is 2 microwatt. So 45 equals to 10 log big power on top, small power on the bottom. Because this is amplifier, output should be bigger than input. So output should be on top. Output on top. Then after that, maths. Maths just rearrange, you get the output power. Okay. Okay. Next. A signal having a power of 2.4 microwatt is amplified into two-stage amplifier. A signal having a power of 2.4 microwatt, it amplified in a two-stage amplifier, two times amplified. The first stage was 18 decibel. And the second stage provides 25 decibel of amplification. Calculate the total gain of two-stage amplification. This is the benefit of using decibel. Just simply add both decibels, 18 plus 25. So both the total amplification is positive 43 decibel. That's the total amplification. Okay. The next, the power output signal from the amplifier. What is the output of the amplifier? So you have two stations. Input, you know already. Input is how much? Input is 2.4 microwatt. They're asking what is the output after passes the two amplifier. So we know both together decibel is 43. So we just put 43, 10 log, the final output over the input. Output big or input big? Output big. So you put the output on top. Okay. Divide by 2.4, you get the output power. Any questions? No questions. Okay. So power on top, we put it as greater than bottom. Okay. Okay, now we slowly moving to the purpose we are learning this knowledge. What is the purpose? We want to help the companies to find what is the furthest distance. You can put the amplifier. Okay. Okay, so to understand that, now we're going to learn this, something called attenuation per unit length. Okay. So now we go to the transmitting medium. Optic fiber, coaxial cable, wire pair. Every mode of transmission, they will have their own attenuation per unit length. Greater the attenuation per unit length means very poor transmission. You need to put the amplifier nearer. If that cable has a very low attenuation per unit length, then you can put the amplifier further. Okay, so that's called attenuation per unit length. A transmission line has an input power of P2, the output power is P1 as illustrated in the diagram. The P1 is the output, P2 is the input. The attenuation is 10 log P2 over P1. Big over small, P2 over P1, total attenuation. Big power on top, small power on bottom. Okay. So this is the total attenuation of the signal. Divide by the length of the cable, you will get attenuation per unit length. Just total attenuation divided by the length, you get the attenuation per unit length. It is called attenuation per unit length. Okay, this formula you no need to remember, also fine. The important formula is the 10 log P out or P in or whatever. The big power over the small power. This is the important formula. Okay, so one example. Look at the question and answer. Hope you understand. The input power of a cable is the input power of a cable of length of 25 kilometer is 500 milliwatt. Okay, there is a cable. The input is 500 milliwatt and the length is 25 kilometer. The cable has a attenuation of 2 decibel per kilometer. Every kilometer it has 2 decibel. That means 25 kilometer will be how many decibel? So 25 times 2. So total attenuation here is 50 decibel. The cable has a 50 decibel of attenuation. Calculate output power. Okay, output power. So the total attenuation is 2 times 25. 50 decibel is the attenuation. So 50 equals to 10 log. Big power on top. In this case, who's the big power? Input, output. It's a cable. Attenuation. Input greater, output greater. Input greater, right? Because attenuation. Okay. So 500 must place on top. Output must be at the bottom. Then you get the answer for the output. If you put this power messed up with this power, your answer is going to be wrong. So be careful. You put big power on top, small power at the bottom. Okay, so this question tells how to use attenuation per unit length information. The cable has a 2 decibel per kilometer. The length of the cable 25. You just times the length times 2 decibel. You get the total attenuation. Okay, any questions from here? No questions. Okay, let's proceed. Okay, now we already come to the final point. Distance to amplify. Where do we need to amplify it? Which is the maximum distance is critical to do amplification. Okay, to find where you need to put the amplifier, we rely on another information called signal to noise ratio. Okay, to put amplifier, where you want to put the amplifier, the greatest distance, the signal, we need to know what is the signal to noise ratio is required. If we're getting lower than signal to noise ratio, lower than this ratio, then you can't recover the signal. Okay, so an important factor, the minimum signal to noise ratio that effectively provides a value for the lowest signal power allowed. Okay, so as I said, this signal to noise ratio, when the signal travel further, what happened to this signal to noise ratio? Getting smaller or getting bigger? Signal get bigger, the noise gets stronger, so the ratio going to get smaller and smaller and smaller when get further. So we have to amplify it before it reach the minimum signal to noise ratio permitted. Okay. Okay, yeah. So for example, in the previous example, the background noise is 5 times 10 power negative 13 watt. Okay, the minimum signal to noise ratio permitted is 20 decibel. Then what is the P minimum signal power can be allowed in the cable? What is the lowest power output, the minimum power allowed in the cable before it need to be amplified? So what they put? 20, 10 log. Here, the P signal, the minimum power, we put it on top and noise at the bottom. Signal to noise, signal on the top. Signal power is on top and the noise, right? The noise is at the bottom. The power on top is P minimum. We put P minimum. Means what? The minimum signal power per meter lah. If the power get lower than that minimum power, you cannot recover the signal back. Okay. So we want to find what is the minimum power the signal can have before it amplified. So we get the P minimum by using signal to noise ratio value. In this case, they said signal to noise ratio value is 20 decibel. So we put 20, we find the P minimum. The P minimum for this signal is found to be 5 times 10 power negative 11 watts. Means what? Original power is what? This is a continuation of the earlier question. Original power is what? Original power is what? 500. 500 milliwatt. No, original power. Original power for 500 milliwatt. Now the lowest it can go is 5 times 10 power negative 11 watts. If the power of this signal go lower than that, pointless you do amplification. You must do amplification before it reaches this or at this point. Okay, now you see. So now you know input is 500 milliwatt. Output minimum power can go is 5 times 10 power of negative 11 watt. 5 to 10 power negative 11 watt. So you know input, you know output. You can find the length, what length required for the cable before we do amplification. How do you find this length? First you do what? Find the total attenuation for 500 milliwatt become 5 times 10 to the power negative 11 first. So see, this enables us to find the maximum and interval length of cable along which the signal can transmit determine. So maximum loss in cable is the total attenuation. We are checking 10 log 500, the input on top because power is big over the minimum power we put it at the bottom output. We found that the cable can have attenuation of 120 decibel before it can be amplified. We have to do amplification before the attenuation reach 120 decibel. Okay. So now how do you find the length? Our focus is what length? So the cable used 2 decibel per kilometer, right? The length is used earlier is 2 decibel per kilometer. So the length required for the 120 decibel to occur is 120 divided by 2, 60 kilometer. That means what? The power going to drop to minimum power after it travel to this cable 60 kilometer away. So this is the information you must tell to the company, okay, telecommunication company, that from your calculation is found that the power minimum power will be achieved when a distance of 60 kilometer after the signal travel. So the company will decide, okay, let's we put an amplifier at 60 kilometer or maybe 40, 58 kilometer, depend on 60 kilometer is the best. If they put 60.1 kilometer, they lose the signal, 60 kilometer. So the company will go every 60 kilometer, place the amplifier. Uninterrupted coverage with minimal cost, most very cost effective. Okay. Or what they can do, change this cable. Change this cable. Use a cable which has a low attenuation per unit length. Use a cable which has a low attenuation per unit length. Instead, you use a cable with 2 decibel per kilometer. Use another cable which is maybe 1 decibel per kilometer. Like optic fiber, very low attenuation. You can put amplifier even further away. Okay. Yeah, this is the final part. How to find distance, the distance required to put the amplification. The important information they must give you is the signal to noise ratio. Use the signal to noise ratio, find the minimum power. After you find the minimum power allowed in the cable, the input and the output, use the total decibel. Okay. After total decibel you get, then the total decibel divided by the attenuation per unit length of the cable used, then you get the distance. Any questions? So you must understand the flow. Okay, so let's go one complete question. Okay, this is one complete question. Look at the question, look at the answer. Try to understand. This is one complete question, finding what is the maximum distance you need to put the amplifier. Read the question, look at the solution. Try to understand. 2 minutes for you. Okay, students, can able to understand the working? So the input signal is 7 milliwatts. So they have a cable. The input is 7 milliwatts. The average noise power, the average noise power, the noise given is this much. This is the noise. Noise later is used to find the minimum power. And the signal to noise ratio is cannot fall below 24 decibel. 24 decibel is used to find the minimum power. The fiber has an attenuation of 1.8 decibel per kilometer. First question, what is the minimum effective signal power is allowed? So we're looking for P minimum. What is the minimum power can be allowed here? So we go signal to noise ratio. 24 equals to 10 log P minimum over the noise. So we get the minimum power. The minimum power can be in the cable is 1.38 times 10 power of negative 16 watts. 7 milliwatts can drop to 1.38 times 10 power negative 16 watts. Okay. So now, what is the maximum length it's required? So 7 milliwatt to drop to 1.38 10 to the power of negative 16 milliwatt. What is the, how many decibel is the attenuation? So attenuation is 10 log input over output. Why input? Because input is bigger, right? Input on top 7 milliwatt, down is 1.38 times 10 to the power of negative 16 milliwatt. Here be careful. The power unit both must be same. Both change to watts. So 7 times 10 to the power negative 3 over 1.38 times 10 to the power negative 16. Make sure the unit is same. Power. The total decibel of the cable found to be 137. So what is the length required? 137 divided by 1.8. 76 kilometer. Okay. So you need to put amplifier after the signal travel about 76 kilometer from the source. Any questions? Everyone can understand? No problem. Okay. Let's we go ahead. Okay. This one pass here. Read the question. 2 minutes for you. Try to get the answer. Okay, so you got the idea. The signal is transmitted along a cable. Total length is 125, 125 kilometer. The cable attenuation is 7 decibel per kilometer. Every 1 kilometer of signal travel, the attenuation is 7 decibel. But it's 125 kilometer, the total length of the cable. So the total attenuation, how much? You can calculate, right? Total attenuation for 125 is what? 125 times 7 lah. That's the total attenuation in terms of decibel. Okay. But amplification also done in between. Amplification is 43 decibel every 6 kilometer interval. It means total amplification is how much? What is the total amplification? How many amplifiers are there in under 25 kilometer? So under 25, you by 6, right? You get the number of amplifier.
20.8, so 20, right?
So we go for 20, yeah. So we go for 20 amplifier times with 43, right? Decibel. That's the total amplification. This is the total decibel of amplification. Under 25 times 7 is the total decibel of attenuation. Happens. Okay. So first answer. State what is meant by attenuation. Okay. Attenuation is reduction in the process of reduction in the signal power. It's attenuation. AB. Calculate the total attenuation, total amplification. Just now we did. Okay. So next slide. Total attenuation is 125 times 7, 875. There are 220 amplifiers. So total gain amplification is 20 times 43, 860 decibel. Okay. Attenuated 875. Amplification 860. That means overall, as an overall is amplification and attenuation. Overall. Overall is actually an attenuation line. Total attenuation how much? 875 minus 860. 15 decibel is the total attenuation. Okay, see the input signal has a power of 450 milliwatt. What is the output signal? Input is 450. Output is how much? Here got attenuation, amplification happens concurrently, but total, you know, it's attenuation how much? Attenuation of overall gain is what? Overall gain is only 15. Attenuation. Overall is 15. Okay. So overall gain is 15. So here the working is, you must put 15 according to my way. The attenuation, we always put attenuation or amplification, we put here positive. 10 log, we always put big power. P1 over P2. The P1 should be greater than P2. We follow this style. We follow this style. So in my style, I told you, if a power on top, you always want to kept as big means. The decibel here in front must be always put it as positive. Okay.
Sometimes positive, right? Depends on its attenuation or its amplification.
Yeah. Let's say here amplification, let's say higher, 900 decibel. So 900 minus 875, right? So you get again. So here you still put positive 25, always positive 25, but you try to change this power. Top power must be always bigger than the bottom. Okay. So here, but in the mark scheme, you see, they put negative 15. Negative 50. If they put here from negative 15 or positive 15, they are changing the value. That means here they're going to keep the power, they're going to keep always output over input. According to this working, the 10 log, the power, right? They always want to put output over input. They fix the power, always output, input. Doesn't mean up big or down big. They always go for output over input. But then the decibel here can be positive, negative. This is another way. Okay. I'm teaching you the second way. Big power on top, small power at the bottom. Here the decibel always you put it as positive. Okay. But in our system, what's the problem you're going to face? When you deal with amplification, attenuation occurs simultaneously. Then when you add them, make sure the attenuation you change to negative, it's minus, and amplification take as positive. Then you add them, then you get the effective total attenuation. Okay, choice is yours. You want to go for the first technique, my technique, or you want to go this technique also can. If you want to go this technique, it always output over input, regardless of the which power, down power can be bigger sometimes, but the decibel here can be positive or negative. Another method. Any questions you don't understand? Okay. Okay, yeah. So that's about cable. Okay, that's about cable. Any questions you have? Okay, we don't have questions. We'll be doing the questions later. Got many questions at the back. Okay, in the past years. Okay, so next after this, all going to be facts. Last part we're going to talk about is satellite again. We did how the mechanical property of the satellite, what launching speed, what is the orbital speed, how far away it need to be launched from the Earth's surface. When we discuss about gravitation, when we talk about gravitational topic, we talk about satellite. Okay. So now we're going to talk about satellite in terms of telecommunication side. what type of frequency to be used. Okay, how many type of satellites are there? That's what you're going to discuss. Okay, why communication satellite is needed? Why we need to launch satellite? Can we have signal without satellite? Why we need to have a satellite? Because satellite is needed because of some reasons, which we already discussed earlier. The long distance communication using radio wave is possible in medium wave, short wave band. However, there are major disadvantages. Okay, skywave not reliable. Although it's global, not reliable. Why it's not reliable? Because the signal reflected at ionospheric reflection. They say the layer of the ionosphere is prone to weather. If weather is bad, like raining, thunder, it seems ionosphere is thinner. So what happened? The signal won't reflect it back, it seems. So you won't get signal. So skywave is unreliable. Okay. Surface wave, poor reception in the hilly areas. You go to hilly places, surface wave can't really spread. Okay. And another big problem is all the small wave band, earlier wave bands, medium wave, short wave, already crowded, already used up by other radio stations. And the available bandwidth for the smaller frequencies are small, too narrow to carry required information. So rich company forced to come out with a big frequency. When they go for big frequency, I told you, you stand to the ionosphere can't block it. It penetrates the ionosphere. So we need to have a satellite. Okay, so satellite communication enable more wave bands, new wave bands. High frequency can be explored, which can have a convenient, a big bandwidth because nobody using that frequency. Made available at much higher frequency, thus giving a rise to a much greater data carrying capacity. So your HD 4K videos are able to transmit it because the satellite signal has a big bandwidth, and yeah, that's the reason we need satellite. Why you need satellite? These three reasons lah. Skywave unreliable, surface wave poor in hilly places, the lower wave bands already crowded, and the bandwidth for lower wave band is small, cannot send quality information. So we need to have satellite. Reasons, you have to know why we need to have satellite. Any questions from here? Okay. So principle of satellite communication. A frequency, a signal will be sent to the satellite with a certain frequency up. When reach the satellite, I told you satellite's job got two jobs. What is that? You reflect the signal, but before you reflect the signal, it will amplify the signal because highly attenuated signal, like go very far distance. Then when it's sent down, it uses another frequency, F down. The frequency need to be different because to prevent something called swamping to happen. What is meant by swamping? If you send a weak frequency power to the satellite, and when you amplify it, you amplify with the same frequency as the incoming frequency. What happened? Weak energy, high energy. If it's same frequency, what happened? Resonance happened. The energy of the strong frequency energy will be transferred back to the input. Transfer back to the input due to resonance. So what happened? The signal cannot reach the earth back. No energy because energy has been transmitted back into the input due to resonance. So this is called swamping. Okay. So yeah, I go to the fifth point straight away. The carrier wave frequency F up and F down are different so that the very low power signal received by the earth is not swamped, can be distinguished from the high power that is transmitted back to earth. So to prevent that resonance happens, we have two different frequencies. F up always greater than F down. Okay. The value they give for F up and F down is, of course, in gigahertz. It will be 6 to 4, 1411, 3020 was used. Okay. 1 year they asked this frequency. Tell me the frequency up, frequency down, one suggestion. 64, 1411, 3020, one of the answer. That means you have to memorize this fact. Okay, frequency up, frequency down, 64, 11, 1411 or 3020 to be used. Frequency up is greater than frequency down because frequency up, we have plenty of energy at the ground. So we can use very high frequency. High frequency means more energy. We can send them. But satellite has a limited energy. That's why you use minimum energy possible to send it down. It's just nice to reach the Earth surface. So it uses lower frequency than the up. That's why up is greater than down. Any questions? Okay, no questions. Remember these three values. Okay. Satellite got two types. The first satellite, which really highlighted in our geostation, what do you call gravitational topic last time, is called geostationary satellite. A satellite that orbits the Earth above the equator, which has a period of 24 hours, which move the same direction of rotation as the Earth rotation, from west to east. It rotates from west to east. Okay, these are the three property of geostationary satellite. In exam, they'll ask, what is the property of geostationary satellite? There are three properties. The orbit is above the equator. Orbit of the Earth is above the equator. The period is 24 hours. And it rotates the same direction as the Earth rotation, from west to east. Remember, three property of geostationary satellite. Okay, if the satellite is orbiting in the same direction as the direction of the rotation of the Earth, then the observer on the Earth, the satellite will always appear to be above a fixed position on the equator. So yeah, if you launched, it will be always stays in the same location of from the Earth. Astro, the type of satellite launched by Astro, the Measat, is actually geostationary. So the satellite dish on the Bukit Jalil, it always fixed at one direction because it always linked to that same satellite. Satellite appear to be always above that dish. Okay, so this is one type. This geostationary satellite got some advantage and disadvantage. The advantage is it always in a fixed position. So what is the benefit? You always have a permanent link. Permanent link means what? You always connected. Okay. If any live telecast is going on in let's say in a certain country, let's say Malaysia, so you want to broadcast that let's say football for 1.5 hours. So 1.5 hours, the satellite can take the recording of that 1.5 hours and can send to the different part of the world by sending to another satellite and broadcast there. Why this possible? Because it has a permanent link. It always above that area. So a number of satellites with overlapping areas can maintain a communication with any point of the Earth surface. Yes. You have few satellites really can cover whatever happens in the surrounding the world. I think you need only three. 3 satellites, I think, is enough to cover the entire world. This is advantage, permanent link. So although there is advantage, there is do have disadvantages. Disadvantage is it cannot cover the polar region. You see the light shines there, you see? This is the region it can cover. It can't reach the North Pole or the South Pole. So any incident happen at the North Pole, it can't cover that region. Okay. So equator satellite, impossible to cover the polar region. Another one disadvantage is there is a delay receiving the signal about 0.24 seconds. That means the signal from ground go and reach the satellite, and from the satellite reach back to the ground, it takes a significant delay, 0.24 seconds, and slightly longer. Okay, that's why you can see CNN in CNN, the interviewer will be from US maybe. The guy who are interviewed by maybe from Japan. So two different world. I say and the first interviewer, when I ask question, you can see there is a delay because the other guy won't immediately will answer. He'll wait for the question to be reached to him, because the question is go to the signal is going to the satellite and reach to the east country. It takes time. Go to the satellite, they send to another satellite, and that satellite broadcast get to him, and he go and talk his answer. So there is a long delay. That's one disadvantage. Even you watch live telecast, World Cup, say when Germans scored the goal, and when you see, I think you will have about 0.24 seconds or more than that a delay to see here. Okay, although it's live telecast, but actually not real live telecast. Slight, there is a delay. Why this delay is so significant? Because the satellite is very far away from the Earth's surface. The distance is very far. That's why delay is huge. Can you put this satellite closer? Can you put the geostationary closer to the Earth so that the delay is shorter? What's the problem you face? The period won't be 24 hours, right? Yes. When the satellite which is launched nearer to the Earth will have a period longer or shorter? Shorter. You get a shorter period. Oh, that means it make more faster round. So you launch a satellite, after 24 hours later in the morning, you go and check, the satellite won't be there. It will be more head in front, already past our country. So we lose the satellite. Okay. So yeah. So you have to be a permanent distance, and the distance found to be very far away, which produces a period of 24 hours. Okay. That's why it causes this delay. So how to overcome these two problems? Need to cover the polar region at the same time to have a shorter delay. So they said you have another satellite. That satellite called polar satellite. Okay. This is polar satellite. Polar satellite is launched to overcome the problem faced by geostationary satellite. Okay. 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 Now, okay. So now, how to overcome this polar satellite? The polar satellite move from North Pole to South Pole. You go move to North Pole to South Pole, and the orbit is very close to the Earth. Okay, it would be very close to the Earth. Very close to the Earth. Okay, so when it's very close to the Earth, so what happened? The time delay will be shorter. The time delay will be shorter. Polar satellites are satellites that have a low orbits pass over the poles for a period of rotation of only 90 minutes. That's a rotation of 90 minutes. So the result of rotation of the Earth, each day orbit above every point of the Earth's surface. Each orbit crosses the equator 23 to the west. Yeah. So it's only 1.5 hours of period. So when you make one round and come back to the, let's say, first round, it passes the Malaysia, let's say. After one round later, when you come back to the position of Malaysia, the satellite is already turned to the, the Earth is already turning to the right. So what happened? Now you're going to pass maybe Indonesia, the Sumatra. Okay. When you go another one round, you're going to pass further to the Indian Ocean, and so on. So in one day, it can cover the entire world. Okay. So each orbit crosses the equator by 23 to the west. So you go 23 to the west. Okay, cover the west. Yes. So this is polar satellite. Okay. Any questions? No questions, huh? So polar satellite is very close to the Earth. The time delay is very short. Okay, but polar satellite also not perfect. What's the problem of polar satellite is it can't have a permanent link. You can't have permanent link with polar satellite because you're not going to be above Malaysia every day. Okay, you're going to go around the world, so you have to track where it's about. Okay, you have to track where it's about. So the dish, the satellite dish on the surface of the Earth will be always rotating to search for the satellite. Okay, and so tell me, which satellite is best for GPS, Global Positioning System?
Equatorial.
Geostationary or polar orbit? What do you think? Polar orbit. Polar satellite is used for GPS. Okay, why? Because the time delay is too short. Time delay is too short. So if you use geostationary for GPS, I think by the time it asks you to turn left, I think you already missed the junction because the delay is a lot. So we use polar satellite. And not only one polar satellite giving you the GPS. There are many solar satellite, many hundreds of polar satellite working together to cover the world for GPS. So when one polar satellite passes the what do you call passes the Cal region, maybe another polar satellite will come pass by the Cal region in a short while. So the information from every polar orbit satellite will be gathered and supplied to you to give you the GPS, the what do you call the track of where to go. So polar satellite, not only one, many polar satellite works together to communicate, to give your directions. Okay, so polar orbit is good for the GPS. Weather forecast, polar satellite is used because very close to the what do you call atmosphere. Geostationary used for live telecast. Geostationary used for live telecast, used for phone calls. We call geostationary. Okay, because direct link is always needed. Polar satellite used for GPS, for weather forecast, for spying. Okay, US spy other countries. They use polar satellite and quite close to the Earth's surface, so you can take a very clear images compared to geostationary. And the polar satellite can cover the entire world. Okay, so it only 90 minutes. That means you can imagine how close it is to the Earth's surface. Any questions? Okay, no questions. So in exam, they will ask plus and minus about these two satellites. Okay, so remember the plus and minus. The advantages in geostationary is the disadvantage in the polar orbit. Fixed position, permanent link, polar orbit don't have permanent link. Okay, disadvantage of geostationary is the advantage of polar orbit satellite. Okay, communication of polar region, geostationary not possible. Polar satellite is possible. As a huge delay for geostationary. Polar orbit, the delay is less significant. Okay. Yeah, so disadvantage of polar satellite. Continuous communication with a single polar satellite is not possible. Way to overcome. Satellite, while it is overhead, the data store transmitted back to the Earth when it's over the appropriate area. Using a number of polar satellites in orbit that are inclined to one another so that at least one satellite is always above the transmitter and receiver. In this case, the aerial must track the satellite in their orbits. Okay. So few satellites must work together to have a continuous, what do you call, communication. Okay. So the polar orbit is only about 879 kilometers away. Geostationary is how far away? 3.6 times 10 power 4 kilometers away. 36,000 kilometers. This is 36,000 kilometers. These are only 879 kilometers. So you can see the big differences distance from the Earth, the two satellites. Okay, so yeah, that's all. That's all about telecommunication. Okay, we're done with the telecommunication. Any questions? You guys, any questions? No questions. Okay. No questions, Okay. So what you learn about in telecommunication from the beginning? You learn about the mode of transmission, coaxial cable, wire pair, what else? Optic fiber, radio wave, microwave. Then second slide, you learn what? You learn about why you need to do modulation, FM, FM modulation, FM and AM. Then we learn about why analog digital, what is the advantage, disadvantage, we did yesterday. Then today we learn about what is meant by attenuation, how far away the amplifier need to be placed so that can amplify successfully and cost saving. And second, we learn about the type of satellite. There are two types of satellite, polar orbit and geostationary. What is geostationary satellite feature? As a period of 24 hours, always above the orbit is above the equator and always move the same direction as the Earth rotation from west to east. Okay. Why satellite communication is required? Because there is some downfall for the earlier technique. Skywave not reliable. It depends on the weather. Surface wave bad in hilly places. Lower wave bands already crowded and it's a short bandwidth. So we need satellite. Okay. Okay. So yeah, so these are the questions at the back. You can give a try. We're done with this thing. It's all are the AM, FM. Okay. We can go to that one paper. Okay, so I have the compilation. Okay, you can do this compilation. Okay, the questions are repeated. I think I done with all of them already. Okay, some questions here. AM, power supply, and so on. Frequency modulation, satellite transmission, loss of signal power. Okay, suggest the frequency of signal that is set back to Earth. Yeah. Okay, so you can give a try these questions. It's rigid questions. Okay. Your paper is next week, right? Yeah. The exam starts when? When is your physics paper next week?
Tuesday.
Tuesday is your physics paper. Okay. I believe that at the background you're doing the trial papers and everything. Okay. I know it's a very challenging time. Every year is like that. The actual 8-2 trial papers will be like just hit to hit. It's going to be like 2 or 1 day before we'll be finishing the syllabus. Okay. So just give a try, your trial. And your trial, how long? 2 weeks? 2 weeks or 1 week? 2 weeks?
Around depends on for others.
So is after 2 weeks you got a break for 1 week, is it? Can't remember.
How long is the break?
How long is your break? 1 week, right? 1 week break. No, you can't see. So okay, let me check. Okay, I'd like to tell you something. We finished the syllabus, but I tell you, actually telecommunication is not coming up for your trial.
Oh.
Okay. So telecommunication not coming up for your trial, but anyway, good to know because important is your actual exam. Okay, that's why I plan to finish the syllabus. And another one which is not coming out is your medical. Medical is what? Your ultrasound. Your ultrasound not coming out. Your ultrasound, MRI, CT scan, X-ray not coming out. Okay. So the others, yes. From amplifier, op-amp onwards, you have questions. Okay. So just for your purpose of trial, I think maybe you can skip your telecommunication if you want. Okay. You can ultrasound also you can skip for time being, where for the sake of trial, you focus to other topics first. Okay. Then after your trial, maybe you come back and try to reinforce your telecommunication again. Okay. Okay. So tomorrow, what I want you to do is doing the trial papers. Okay. There are lots of trial papers here, and we also have past years. Okay. Maybe we can try to do the first paper for July 16. Okay. Your first paper, Monday, do you have any exam?
No.
So your first paper is physics, right?
Yes.
Okay. Yeah?
And maths.
Physics and maths, huh? Okay. Okay, guys. Can you give a try this paper? Paper for July 16. Okay. Try this paper maybe today. After this also you can start doing. Give a try this question. And tomorrow we discuss this paper. One paper. Okay. Paper for July 16. You can start do now itself. Okay. You have plenty of trial paper. Okay. If you're interested, you can explore this. Or you want to go for past years, straight away you can go for past years if you want to do. Past years, my suggestion is go and do the recent papers, the 20s, okay, the 20s papers.
Okay.
Okay, so tomorrow we'll do paper for July 16. We discuss. Okay, any questions, guys? No questions, eh? I don't want to go through the telecommunication past year. It's there, but I think let you spend more time to your trial first. Okay. So and workshop paper 4 is here. If you want to check, you can go. Do you went through the workshop yesterday, paper 5? You went for the workshop, paper 5. Okay. Any questions? No questions. Okay, so tomorrow I get back to you. But tomorrow I want you to, we will be discussing this. You can do now itself if you want. Do the paper, the first paper. That's it. Okay. Yeah, paper July 14, 16. Okay, so I stop here. Any questions?